Chapter 8, Confidence Interval Estimations. The learning objective of today's lesson is that at the end of today's lesson, you'll be able to construct and interpret confidence interval estimate for the population mean and population proportions. And you'll also be able to determine the sample size necessary to develop a confidence interval for the population mean or population proportions. So just a recap for chapter 7, we talked about two situations. The first situation is when we have the population mean with the sigma known. So when we know the population standard deviation, that is the first situation that we talked about. The second situation that we talked about is population proportion. So when we are given percentage, then we know that this is population proportions. And in the two situations that we talked about in chapter 7, the population mean with population standard deviation known, and the population proportion, in these two situations, we're dealing with Z distribution. So we're dealing with normal distribution, Z distributions. So those are the two situations that we talked about in chapter 7. In chapter 8, we're going to introduce a new situation. And that situation is when we have the population mean with sigma unknown. So when we don't know the population standard deviations, that means we're given the sample standard deviation. So when we're given S is your sample standard deviations, then we have to use T distribution. So we're introducing a new situation, and then we're going to introduce a new distribution called the T distributions. So again, we have three situations. First situation is population mean with sigma known, so we know the population standard deviations. That's the first situation. Second situation that we had was population proportion. When we're dealing with percentage, then we know that we're dealing with proportions. And in these two situations, we have Z distributions. In chapter 8, now we're introducing a new distribution called T distribution. And when do we use it? Is when we're given the population mean and we don't know the population standard deviation. And when we don't know the population standard deviations, what that means is that we're given the sample standard deviations. So those are the three situations. And the definition for confidence interval is, for example, I gave you 95% confidence interval. The 95% confidence interval represent that you're 95% confident that your interval will contain the population mean. So the confidence interval shows how confident you are. It doesn't tell you the probability. We're not claiming that it's 95% probability that the interval will contain the population mean. We're not claiming that. What we're claiming is that we're 95% confident. And this is what the confidence interval is about. We're 95% confident that the interval will contain the population mean. And when we're looking at 95% confidence interval, the 95% come from 1 minus alpha. So if you have a 95% confidence interval, that means your alpha is 5%. So your confidence level plus your alpha has to add up to 100%. So if you have 95% confidence interval, then your alpha will be 5%. Similarly, if you have a confidence interval of 80%, that means your alpha is 20% because these two have to add up to 100%. If you have a confidence level of 90%, then your alpha is 0.1. If you have a confidence level of 95%, then your alpha is 0.05. And the last example that I give you is that if you have a confidence level of 98%, then your alpha is 0.02. So alpha and your confidence level has to add up to 100%. And then from a diagram perspective, in this diagram here, we have your 0. So 0 is your standardized value for your mean. And then we have a normal distribution graph here. And in the 95% confidence interval, that means we have 95% in the middle. And since we have 95% in the middle, and we know that the total area of this diagram is 100%, so therefore we have 2.5% on each side because the diagram is symmetric. So 100% in total minus 95% in the middle means that we have 5%. And then we take the 5%, we divide it by 2 on each side. So we have each side, we have 2.5%. So for each side, we have the alpha over 2 because our alpha is 5%. And in previous chapter, we talked about the margin of error. We talked about that margin of error is basically the gap between your point estimate and your upper limit. There's also the gap between your point estimate and your lower limit. That's your margin of error. And because this is symmetric, so what we can do is we can take the margin of error and then we can times it by 2. That will give you the confidence interval. So that's the gap between x1 and x2. So 2 times the margin of error will give you the gap between the x1 and x2, which is your confidence interval. So next we have a bunch of formulas here. So the formula for margin of error is confidence dot norm if it's normal distribution. And if it is t distribution, then we use confidence dot t. So two formula for the margin of error depending on whether this is normal distribution or t distributions. And we have the three situations here. The first situation is confidence interval for the population mean with sigma known. So when we're dealing with confidence interval for population mean with sigma known, we use the same formula that we used in chapter 7 to calculate the confidence interval. And then same for confidence interval for population proportion, we use the same formula that we used in chapter 7 to calculate the confidence interval. Lastly, what is new with this chapter is that for chapter 8, we have a third situation, which is the population mean with sigma unknown. So when we don't know the population standard deviations. And for us to calculate the confidence interval, we need to use the formula x bar plus minus the t alpha over 2 times s divided by square root n. This is the formula that we're going to use to calculate confidence interval. And then t alpha over 2 is basically your t critical. To calculate t critical, we're going to use t.inv. It will ask you for two variables, probability. Probability is basically your alpha over 2. And then your degree of freedom. Degree of freedom is n minus 1, which is shown here. Is always going to be n minus 1 when we're dealing with t distributions. So x bar is your point estimate. Critical value is your t alpha over 2. That's your critical value. And then your standard error is now your s divided by square root n. The reason we're using s is because we don't have the population standard deviation. Population standard deviation is unknown. All we're given is s, our sample standard deviations. So sample standard deviation divided by square root n, that's your standard error. So that's where this confidence interval formula comes from. It's basically point estimate, which is your x bar, plus minus the critical value, which is t alpha over 2 for t distributions. And then your standard error is s divided by square root n. And this is the confidence interval formula for the new situation that we have. So we're going to go through example 1 right now, and I'll show you how to apply this formula.